Alright, welcome back. Alright, now that we understand that we're going to get this information about how the ocean is changing from a type of numerical model, well, that is coupled to our atmospheric models, what can we actually learn about near-term changes in the ocean between now and, say, the middle of the 21st century? Well, I hardly needed to show you a diagram like this, right? This is global mean sea surface temperature change with respect to, I forget, 2005 or something like that, in the models. And you probably noticed that all of these curves are pointing up. I mean, before you even examined these curves in the IPCC report, you noticed immediately, unsurprisingly, that they're all pointing up. You probably could think through as to what's going on here, is that these curves, notice how they have kind of error bars around each of them? Well, that is the range of forecasts of global mean sea surface temperature in each member of an ensemble. So each, like, the pink area or the purple area or whatever, that is the area that represents, the range of forecasts of the 42 members of the ensemble. They ran those 42 models, each for each of 4 different sets of boundary conditions, RCP 2.6, 4.5, 6.0, and 8.5. So we have a set of these runs, okay? And you'll notice that even with those error bars in there, not a single one of these curves is aiming up, going down, right? All show ocean temperatures that are increasing between now and the middle of the 21st century. Well, unfortunately, that's not so horrifying. I mean, that's not so surprising. I actually just extended over from 2060, just so you can see, like, the blue curve there, which is the RCP 2.6, the unreasonably small amount of greenhouse gas forcing, that results in an additional 0.8 degrees of sea surface temperature increase worldwide, whereas, like, for example, the red curve, which represents RCP 8.5, which is a relatively high amount of radiative forcing due to anthropogenic greenhouse gases, kind of close to that scenario A1FI, where we are very fossil fuel intensive. That one has more like 1.5 degrees of warming. And I do want to point out that is warming with respect to the 1986 to 2005 average. So, like, I mean, if I just pull up this paper right here, we've had already about 1 degree Celsius of sea surface temperature change since the Industrial Revolution. This paper actually is documenting it in the last 140 years, but whatever. So this is over and above the warming that you're seeing on there before was over and above that amount of warming before. Now, whereas when we talked about changes in air temperature, we saw that a lot of those changes were concentrated in the Arctic. That is not the case when it comes to changes in sea surface temperature. It's pretty much everywhere. If you take a look here on this scale here, I have to admit I don't remember which exact panel this was from an IPCC figure, but this is the output of one of the model runs, and it shows, there's approximately 1 degree of warming between now and the year 2060 or whatever these simulations are. And you can see it's certainly not concentrated in the Arctic. In fact, it's kind of fairly uniform, maybe more in the tropics than other parts of the world. Remember, those colors are showing you the average sea surface temperature increase across all 42 members of the ensemble. And then the stippling on there, those little dots there, are telling you that those areas are areas where the models were mostly in agreement. Okay? There can be some areas where they have those crosshatches where we're less certain of the results because some of the models showed increases, showed sort of decreases, or the range was pretty big, or whatever. It's a measure of, like, statistical significance or something. That's not quite exactly statistical significance, but it's kind of like that. It's a measure of the confidence we have in the results. But no matter what, this is actually really messy and uncertain. Because the truth of the matter is we don't actually know that we really understand how well the ocean's circulation is going to change in response to greenhouse gases. There's a lot of uncertainty about those ocean temperature changes, and especially the ocean circulation changes, even in, like, those relatively near-term predictions. We just don't know how good these ocean models are at predicting big changes in, like, you may have heard the term the Atlantic meridional overturning current, okay, or the thermohaline current, and so on. In the era of which we have observations, We've never made big changes to those circulation systems. So we don't really have a way of testing how good the models are at simulating changes in those current systems. Whereas we have fairly good understanding of like how well the atmospheric components of the model do it under a range of conditions. We experience a range of different conditions every year, right? So it's not so much that we doubt the ocean models or we have reason to doubt them, so much as in there's a source of uncertainty here. We don't have good observations of like the last time the AMO, the Atlantic Meridional Overturning Current, the last time that current collapsed. Because the last time that current collapsed was like 11,000 years ago during the Younger Dryas. Okay, we didn't have observations then. We didn't have, high technology then was bronze. Okay, we don't know what the world was. We don't have measurements so we can simulate that climate and so on. All right. We're going to come and talk more about climate changes that we are going to be expecting in the Earth, atmosphere, cryosphere, land system in just a few minutes. But let's answer two or three quick questions here. Question 5. Some climate models show global mean sea surface temperature to increase between now and the middle of the 21st century. But others have shown these values to decrease, and so the uncertainty in the forecast remains quite high. True or false? How are we interpreting what's going on with regard to global mean sea surface temperature change between now and the middle of the 21st century? Make a choice from those two options and get a little feedback before you move on to question 6.